The concept of moles in chemistry is famously difficult to explain and understand. A mole is an amount of something, so you might say, I have a mole of carbon dioxide, or I have a mole of glucose. By definition, a mole is 6.022140076 times 10 to the 23 particles or things. So what problem does the mole solve for chemists? Well, chemists like reacting things together. So maybe they've got some hydrogen over here and some fluorine over here. They want to react them together to make hydrogen fluoride, but they want to do it in such a way that there's nothing left over. There's no residual hydrogen, there's no residual fluorine. You need the exact same number of hydrogens and fluorines. How do you do that? You could count them out. So you could count out 1 trillion hydrogens and 1 trillion fluorines. You know you've got the same amount of both. There'll be nothing left over if you react them together. But that's impractical. So you could do what chemists always do, which is to weigh out the different chemicals. So you weigh out 1 gram of hydrogen and 1 gram of fluorine, and you've got the same amount of both. Except that doesn't work because fluorine atoms are heavier than hydrogen atoms. So if you've got 1 gram of each, you'll have more hydrogen atoms than fluorine atoms. So what you have to do is look up the relative masses of hydrogen and fluorine, and when you do that, you find that fluorine is 19 times heavier than hydrogen. Like if you were going to react single atoms together, so you've got 1 atom of hydrogen, 1 atom of fluorine, the ratio of the masses in that chemical reaction would be 19 to 1. And so long as you keep that mass ratio the same, you know you'll have the same number of hydrogens as you do fluorines. So for example, if you've got 1 gram of hydrogen, you'll need 19 grams of fluorine. Or you could do 2 grams of hydrogen and 38 grams of fluorine. Or you could do 10 ounces of hydrogen and 190 ounces of fluorine. So long as the ratio is 1 to 19, you know you'll have the same number of atoms in each pile. So how do we know that an atom of fluorine is 19 times heavier than an atom of hydrogen? Well, most of the mass of an atom is in the nucleus because the electrons are so incredibly light. So we just need to look inside the nucleus and see what's there. For hydrogen, the nucleus is just a proton, 1 proton. So we could say that the mass of hydrogen is equivalent to 1 proton. It has 9 protons and 10 neutrons, so it has an atomic mass of 19. And so now we've come full circle. If you measure out a gram of something that has an atomic mass of 1, then you will have an Avogadro's number of that thing.